Hello everyone. Welcome to the course Principles and Applications of Mechatronic Systems. I'm your instructor, Jean-Nissen. Today we look at Chapter 4, Servo Control Technology, Common Instructions of PLCOpen Motion Control. These instructions play a vital role in industrial automation, especially in motion control systems, and are indispensable for accurate control of mechanical motion and complex automated production processes. Let's first clarify the learning objectives of this lesson. We need to master the functions of 14 commonly used instructions such as MC Power, MC Reset, and MC Read Status in PLCOpen motion control. Meanwhile, understand the input and output parameters of each instruction and their respective applications in different practical scenarios. 1. Detailed explanation of instructions. 1. MC Power, Enable Control Instruction. The MC Power instruction is like a switch for the motion axis. Before starting the motion task, it needs to be used to enable the axis so that the axis can respond to subsequent motion instructions. When the task is finished or abnormal, it can be used to disable the axis, stop the movement of the axis, and cut off the power to ensure safety. For example, in an automated production line, it can be used to enable the axis before the equipment is started, so that operations such as transporting materials can be carried out. If there is a sudden failure during operation, the axis should be disabled immediately to avoid danger. 2. MC Reset, Reset Fault Instruction. The MC Reset instruction is used to reset axis fault. When the axis is shut down due to overload, overtravel, and other faults during operation, this instruction can eliminate the fault mark and restore the ability of the axis to respond to the motion instruction. For example, after the fault alarm of a large processing machine tool, eliminate the fault source and use this instruction to make the axis work again. 3. MC Read Status, Read Status Instruction. The MC Read Status instruction can obtain status information such as enable, motion, and fault of the motion axis. Make a logical judgment based on it. If the axis is moving, prohibit the specific operation, and execute it after the axis is stopped to ensure the accuracy and safety of the operation. 4. MC Read Actual Position, Read Actual Position Instruction. The MC Read Actual Position instruction can read the actual position value of the motion axis and is suitable for scenarios that require position comparison or feedback control, such as automated assembly equipment, and is used to adjust motion to ensure assembly accuracy. 5. MC Read Actual Torque, Read Actual Torque Instruction. The MC Read Actual Torque instruction reads the actual output torque value of the motion axis. In the application scenario of load change, it can monitor the load of the axis in real time to avoid overload damage to the equipment. For example, when lifting objects of different weights in lifting equipment, read the actual torque to judge whether the load is within the bearable range, and take timely measures when it approaches the limit. 6. MC Read Actual Velocity, Read Actual Velocity Instruction. The MC Read Actual Velocity instruction reads the actual velocity torque value of the motion axis. In the velocity feedback control system, this value is used to compare the set velocity and adjust the axis motion to ensure the velocity stability and accuracy. For example, the automated conveyor belt system needs to read and regulate the velocity in real time to stably convey the goods. 7. MC Move Relative, Relative Positioning Instruction. The MC Move Relative instruction allows the motion axis to move relatively by a specified distance from the current position. It is suitable for scenarios where the axis needs to move multiple times at different distances without considering the absolute position, such as the tool moving according to process requirements in machining. 8. MC Move Velocity, Velocity Instruction. The MC move velocity instruction allows the motion axis to continue to run at a specified speed until it receives a stop instruction. It is suitable for scenarios that require uniform motion, such as conveyor line transmission control, to ensure conveying efficiency and stability. 9. MC move absolute positioning instruction. The MC move absolute instruction moves the motion axis to a preset absolute position in the motion coordinate system, which is suitable for scenarios where the axis needs to be accurately moved to a specific position. For example, during the grasping operation of an industrial robot, this instruction causes the robotic arm axis to accurately move above the preset workpiece position to achieve accurate grasping. 10. MC jog motion instruction. The MC jog instruction causes the motion axis to move in a jog mode, and is often used in equipment installation and debugging or scenarios where the axis needs to be temporarily moved. For example, when debugging automation equipment, the staff can manually control the slight movement of the axis to adjust the position. When the instruction is activated, the axis moves at the preset speed, and when the instruction is cancelled, the axis stops. 11. MC torque control instruction. The MC torque control instruction is used for torque control of the EtherCAT bus axis, which can set the output torque value of the axis for accurate operation. In scenarios such as tension control, this instruction can ensure the stability and quality of the process. 12. MC homing instruction. The MC home instruction returns the motion axis to the preset mechanical origin, eliminating accumulated errors and providing a benchmark for subsequent positioning. For example, the stepper motor single-axis control system needs to perform this operation when it is powered on or reset for the first time to ensure the subsequent absolute positioning is accurate. 13. MC stop instruction. MC stop is a high-priority instruction. After execution, all movements of the axis are forced to stop without interruption, and stopped according to the preset deceleration curve. It is suitable for emergency shutdown, equipment fault, and other occasions where the axis needs to be stopped immediately. If there is a potential safety hazard or equipment abnormality in production, the staff can trigger this instruction to stop the axis quickly and prevent the accident or fault from deteriorating. 14. MC halt instruction. The MC halt instruction can suspend axis motion, allowing interruption by high-priority instructions such as MC stop. After the axis is halted, it decelerates and stops, and the motion can be resumed by other instructions later. It is suitable for scenarios that need to temporarily halt the axis movement. For example, when it needs manual intervention to inspect equipment or adjust the production process, halt the axis movement first and resume after processing. Comparison of MC stop and MC halt. For better understanding, here is a comparison of the two instructions MC stop and MC halt. MC stop has the highest priority, cannot be interrupted after execution. It will immediately stop the axis movement and cut off the power. It is suitable for emergency shutdown, etc. MC halt has a low priority and can be interrupted. It causes the axis to decelerate, stop and retain power, and can resume motion later. It is suitable for scenarios such as temporary halt. This lesson explains in detail 14 common instructions for PLCOpen motion control, including their functions, parameters, and applicable scenarios, covering enable control, fault reset, axis status reading, motion control, stop and halt control, etc. I hope you can master these contents proficiently so that in future motion control programming tasks, you can reasonably use instructions according to different production needs and scenarios, achieve precise control and effective management of motion axes, and ensure the stable operation and efficient production of industrial automation equipment. That concludes this lesson. Thank you for listening. See you next time.